Hello, this is Dr. Brown, and this video we're going to go over test one practice. These will be the kinds of problems that you will need to be able to work for the test. Let's go ahead and get started. We have the population of a town grew from 4,360 to 6,590 today. And we want to know what the absolute change is. Well, that's going to be the absolute value of the ending, which is 6,590 minus 4,360 equals 2230. And the percent change, first of all, the fractional change is 2230 divided by 6,590, and that is equal to 0.5114, which is equivalent to 51.1%. So the percent change is 51.1%. Now you have a sale for a sofa, which was discounted by 15%. What percent of the regular price does a customer pay? So it's decreased by 15%. So he paid %100 minus 15% equal 85% of the regular price. Now we have a regular selling price of an item of $221, special a year-end sale at a markdown of 20%, find the discount sale price. So he will pay 80% of the regular price, which is 0.8, change it to decimal, times 221 is equal to $176.80. Now, number 4, in 2000, your salary increased by 15%. In 2001, you received a 15% pay cut. After the two changes, how does your salary compare to your original salary? I'm going to do this two ways. The original salary is just S, say. After the raise, which is 15%, the salary was 1.15 times S. Now, after the decrease by 15% means he made 85% or 0.85 times what he was making after he got his raise. So after the decrease, it's 1.15s times 0.85s. And if you multiply these together, you get 0.9775s, which means that he's making less than he was originally. So it is lower. Now, you can use a number S if you desire and say, for instance, he's making $10,000 start. And after the raise, he makes 1.15 times 10,000. Which is $11,500. And after the decrease, he's making 11,500 times 0.85, which is $9,775, which of course is less than the original amount. You could also do this by starting with the 10,000 with a 15% raise. You could calculate the raise amount, which would be 0.15 times 1,000 or 10,000. So his raise is $1,500. So the new salary is 11,500. Add 1,500 to the 10,000. And then 15% decrease. So it decreases by 0.15 times 11,500, which is $1,725. How much his salary goes down. And so the new salary after the decrease is equal to 11,500 minus 1,725, which is 97.75, which of course is lower. Obviously, the fastest way to do it is just to use a symbol and know that when you decrease something by 15%, what you get at the end is 85%, and just keep on doing that. In the 1980s, the population of a town decreased by 10%. In the 1990s, its population increased by 30%. How does the population of Pleasanton at the end of the 90s compare with its population in 1980? Well, the population to start off with is say P, and after a 10% decrease, it's going to be 0.9P, and then an increase by 30%, it's going to be 0.9P times 1.3 represents a 30% increase. You multiply that out and you get 1.17P. So it's 17% higher. Okay, we have a sales tax rate in New Mexico is 6.5%. You buy a car for $36,500. What's the tax on car? Well, the tax is going to be 0.065 times 36,500 is equal to 23.72.50. So it's going to be 23.72.50. Total cost is 36,500. Price without tax plus the tax is 23.72.50, and that equals $38,872.50. And so that goes right there. Number 7, calculate the amount of interest you'll have at the end of the indicated period. This time the period is 5 years. You invest $800 in an account that pays simple interest. The big difference between simple interest and compound interest. The simple interest formula is very simple. It's I equal PRT. P is a principal. So here the principal amount, the amount you start with is $800. The interest rate and decimal is 0.04. And T is 5. So the interest is going to be 800 times 0.04 times 5 is equal to $160. So you'll make $160 interest. Now we want to determine the accumulated balance after the stated period where you're going to have compound interest, compounded monthly, putting in a initial deposit or what we would call the present value of $2,500 and an interest rate of 4%. So PV, here's a formula we're going to use. PV is equal to 2,500. R is equal to 0.04. T is 6 years. And N, the number of compounded periods per year, is equal to 12 compounded monthly. So the future value is going to be 2,500 times 1 plus 0.04 divided by 12 to the NT. Now NT, you can go ahead and calculate that. It's going to be 6 times 12 equals 72. So this is going to be the 72nd power. And I'm going to put this in the calculator. I may let you put some of this in the calculator yourself. I'm going to, depending on the calculator you have, you can do it different ways, but you need to do that calculation there. We're going to put 2,500, and I'm going to do the parentheses 1 plus, and I could just simply put 0.04 over 12, but I'm going to go ahead and do the fractional expression, which is 0.04. And notice I use my cursor to bring, pointer to bring the cursor down so I can put in the 12. And now I need to get to move to the right so that I can put the in parentheses. And now I want to do an exponent, so I use this up arrow, and I put 72, and I can bring it down. I don't think you absolutely have to, and it hit enter. And what I get is 31, 76, 85. Now, number 9, we got a $1,200 deposit. PV is 1,200. The interest rate's quite low, 0.02. Quarterly compound, which means N is equal to 4. And T is 2 years. So FV is going to be 1,200 times 1 plus 0.02 over 4 to the 8th power. I'm going to let you put this in your calculator, and that will be $1,248 and 84 cents to the nearest cent. Now, the same formula, which can be turned around if you would desire some future value, the way to calculate the present value, which is the amount you'd have to put in the bank to get some future value, is this formula. And you want to have $75,000 in the fund in 15 years. So T is 15. N, if it's monthly compounding, N is 12. And the interest rate is 0.06. So we have to calculate present value is equal to 75,000 times 1 plus 0.06 divided by 12 to the negative 12 times 15. You could go ahead and multiply that out. Now I'm going to put this in the calculator. It's a little bit different than the previous one. It's got a negative exponent. So let's give this a try. I'm going to clear it and put 75,000 times 1 plus, and I'm going to use the fractional expression again, 0.06 divided by 12, close the parentheses. Now, excuse me, I'm going to delete that. You don't need to close the parentheses. You just need to put parentheses over here on the right and then close it. And we're going to go to the negative, and I'm just going to let the calculator multiply 12 times 15. And notice I probably didn't have to put this one and this one in, but I just want to be safe. So now hit enter, and we get $30,561.18 is how much you would have to put in. So the answer is $30,561.18. That's how much you would have to put in. So in 15 years, you would have $75,000. Now I want to calculate payments. Calculate the monthly payment for a home mortgage of $117,000. Just ignore the N here. That's a typo. With a fixed APR of 4.3% for 30 years. Here the formula is given. The present value, in other words, the mortgage on the house, will be $117,000. The interest rate is 0.043. The time period is 30 years. And going to make monthly payments. N is equal to 12. So NT is 360. So the payment is going to be 117,000 times 0.043 divided by 12 divided by, in fact, we're going to do this such that we'll have the calculator put in the line here. So we won't even have to use a parentheses for the first one. But we need parentheses here. To the minus 360. Now I'm going to put this one in. Clear the calculator out. 117,000 parentheses, and I will go ahead and do the 0.043 divided by 12. And notice I'm going to try to do this two ways. I'm going to go ahead and divide it, and now I'm going to have to use the parentheses. And now it's 1 minus parentheses 1 plus 0.043 divided by 12. To the minus 360. I want to bring things down and do a right parentheses. Hit enter. And I get 578.99, which would be $579. Now, you can skip forward if you want to, but I'm going to show this again, putting it in slightly another way. Put 117,000. In fact, let's clear this. We're going to start out with a fraction, and we're going to get 117,000 times 0.043 divided by 12. And now I'm going to put in the denominator, which is 1 minus 1 plus 0.043 divided by 12. To the minus 360. Let's enter, we get the same thing, $579 rounded to the nearest tenth, and of course it becomes $579. Now we got two more payment problems. One is find the monthly payment for a home mortgage of $89,000. Interest rate of 3.8% for 30 years. So our PV is 89,000. The interest rate is 0.038. The time is 30 years. And number of payments is 12 per year. So now your payment is going to be 89,000 times 0.038 divided by 12. Divided by 1 minus 1 plus 0.038 divided by 12 to the minus NT, which is minus 360. And you can put this in your calculator and you'll see that this will be $414.70. Now, number 13, we want to calculate the total payments over the term of the mortgage, 30-year mortgage, and you start out with a mortgage of $120,000. So PV is $120,000. The interest rate is 0.06. T is 30. And N is 12. So the payment, one of the 360 payments you're going to make, is $120,000 times 0.06 divided by 12 divided by 1 minus 1 plus 0.06 divided by 12 to the minus 360. Now I'm going to let you put that in your calculator, and you will get, and I want you to leave this in your calculator because we're going to multiply it. Your payment is $719.4606.302. Now notice, I want you to multiply this by the 360, and you'll get that the total payments you make during the life of that 30-year mortgage is $259,005.83. Now, sort of interesting, and I'm not completely sure how the banks do this. If they did this calculation, they might say that your payment should be $719.46. If you multiply that times 360, you get $259,005.60 over the 30-year life. So there's 23 cents difference. I noticed the place where I got this particular problem from provided this answer. I'm not completely sure the banks multiply everything by all the way to 1, 2, 3, 4, 5, 7 decimals. But anyway, you get either answer on the test and you got it right. Here's a credit card problem in which you want to pay off a balance of $3,200 on a credit card, and you want to find out what your monthly payment will be. And you make no additional charges to the card, 18%, and you want to pay it off in 4 years. So, PB is $3,200. N is 12. The interest rate is very large, 18%. And the time you want to pay it off in is 4 years. NT is 48. So we'll use the payment formula and plug in 3,200 times 0.18 divided by 12 divided by 1 minus 1 plus 0.18 divided by 12, that to the minus 48 power. Put that in your calculator and you get $93.9999, which you would round off to $94 per month to pay it off. And that is the practice test.